Good day, my viewers. You're welcome to this channel once more. This wonderful day, we are going to be looking at circle theorems. Now, we are going to be looking at the first four theorems under circle. But before I move on, if you have not subscribed to my channel, please do so that as the video comes, you get it right directly on your phone. And if you have any comments, please use the comment box. And if there's any like and whatsoever, please do so. Now let's move on. We are going to be looking at circle theorem actually, and most people find this topic very difficult. It's actually the most simplest topic that you can see in mathematics. So why do I say so? You are going to see this today. Now let's look at the first theorem. The first theorem says that the angle that an arc will subtend at the center is twice that which is subtended at any part on the circumference. Now we know an arc. Let's draw the circle. Now this circle that I've drawn, a part of it, a part of the circumference from here to here is called an arc. Let's say arc AB. And that's the center of the circle. So that arc AB, the angle that arc will subtend at the center is twice that which is subtended at the circumference. Now if the side of this arc will form an angle at the center, so we are going to be having something like this. Now, if the arc is as big as this, we form this angle at the center. If the arc is as small as this, the angle also becomes small. And if the arc is as big as this, the angle also becomes big. So, anytime you see an arc forming an angle at the center, O, if that same arc, the size of that arc is also forming an angle at the circumference. Now, let's say the angle goes this way. Now, the angle A that was formed at the center and the angle B that is formed on the circumference, those two angles is what the first theorem is all about. This angle here is 2 of this. That shows that whenever this one is B, this one will be 2 times B. So if here is 20 degrees, A will be 40 degrees. That is what the first theorem is saying. So if you understand this theorem very well, we'll be able to apply it in solving exercises or problems that will come across. Likewise, if you are given the angle at the center and if you are asked to find the angle at the circumference, just divide the angle at the center divided by 2, you get the angle at the circumference. So what you needed to take note here is the arc that is forming the angle at the center, and the same arc must form the angle at the circumference. The two lines that is going to the center must come from the beginning and the end of the arc. It goes to the center. While also at the circumference, the two lines also comes from the beginning and the end of the arc and goes to the circumference. So whenever you see that, you know that is the first theorem that says that you can shorten it and say angle at center equals to 2 times angle at circumference. That is the first theorem. We are going to be applying this later in solving questions. Now, this is the first theorem. Now, let's now look at the second theorem. The second theorem is just like this too. It's talking about an arc too. That an arc forms 2 or more angles on the circumference. It says that whenever an arc forms 2 or more angles on the circumference, those angles are always equal. That is what we call angle in the same segment. Now, if I should draw a circle like this, and let's say this arc, let's put it on this side, A, B. If this arc form 2 or more angles on the circumference, that means 2 lines must be coming from the arc and the arc and going straight to the circumference. So let's say we are having something like this. There's the arc AB here. That's one angle that is formed on the circumference. Let's say we are now having another one like this. You can see the 2 lines are coming from the beginning and the end of the arc, going to the circumference, also going to the circumference. Whenever you see an arc forming 2 or more angles on the circumference, those angles on the circumference are equal. So we call them angle in the same segment. You can see the segments here. If you cut here, it gives you the major segment and the minor segment. But that is not important. Just take note of the arc, and if the arc forms 2 or more angles on the circumference, these 2 arcs can also form an angle here. A line will come like this, another line from the second point will also come like this. These three angles A, B, C are equal. So A equals to B equals to C. Whatever A is, that is what B is, and that is what C is. And whatever C is, that is what A is, and that is what B is. That is, angle in the same segment are equal. Theorem number 2. Angle in the same segment are equal. So that's our second theorem, number 2. Anytime you see angle in the same segment, they are what? Equal. Now the theorem number 3 also has to do with an arc too. But this arc is the semicircle arc. Now let's see. What did it say? It says that angle in the semicircle is a right angle. It says that angle in the semicircle is a what? Right angle. Let's see, this is a semicircle. So the whole of this is an arc. It will be forming angle at any part of the semicircle. You can form on this side, on this side. Let's say a line comes from here and from here and come here like this. This angle that is formed in a semicircle is a right angle. That means it is 90 degrees. So this third theorem says that angle in a semicircle is a right angle. That is 90 degrees. Now that is a third theorem. Anytime you see a semicircle, you must be told that that line is a diameter before you can conclude that that is a semicircle. If they just draw a line and you are not told that that is the center, you cannot conclude that that particular line that is drawn is a diameter. Now, anytime you see a diameter and an angle is formed in the semicircle, is a right angle. That's theorem number 3. Now, theorem number 4 that we are going to be looking at is the fourth theorem, the fourth circle theorem. In this case, this one talks about a quadrilateral. It talks about a quadrilateral. If you have a cyclic quadrilateral, a cyclic quadrilateral is a quadrilateral that is inscribed in a circle where the 4 vertices touches the circumference. Now, if you have a cyclic quadrilateral like this, a quadrilateral is a 4-sided shape. 1, 2, 3, 4. Any 4-sided shape is called a quadrilateral. Now, if you have a quadrilateral that is inscribed in a circle, we call it a cyclic quadrilateral. It will have opposite angles. This angle will be facing this angle, while this angle will be facing this angle. Now, this one talks about the opposite angles. The two opposite angles, the theorem says that the two opposite angles are supplementary. So, in a cyclic quadrilateral, the opposite angles are what? Supplementary. That's the fourth theorem. The opposite angle of a cyclic quadrilateral are supplementary. Now, the opposite angles here is angle A is opposite to angle B, while angle C is opposite to angle D. Now, if we say they are supplementary, means that whenever you add the two opposite angles together, it gives you 180. That shows that the angle A and angle B, A plus B equals to 180 degrees. Likewise to C and D, they are opposite. It shows that C plus D too equals to 180 degrees. So anytime you see a cyclic quadrilateral that is inscribed in a circle, and you're able to locate the two opposite angles that are facing each other, any two opposite angles are what? Supplementary. So the addition of the two together will always and always give us 180 degrees. So these are the first 4 theorems that we are going to be seeing today. And in my next video, we are going to be applying these 4 theorems in solving our problems. So after we are done with the 4 theorems, we are going to be looking at the remaining 3 theorems on circle. We have just 7 theorems on circle. So this is where we are going to draw the curtain for today. I hope you enjoyed this video. I hope you have any question. If you have any question, feel free in my comment section, put your comments. And if you have any you like. And if you've not subscribed, please don't forget to do so. I'll see you in my next video. Bye-bye. Have a wonderful day.